Hello guys, welcome to the channel. In this particular video, I will explain the problem maximum depth of a binary tree. This problem is asked by companies like Amazon, Microsoft, etc. So let's start with the problem statement. It says that you are given a binary tree and your task is to find the maximum depth of this tree. And what is maximum depth? So a binary tree's maximum depth is the number of nodes along the longest path from root down to the farthest leaf node. So one example is given here. Let me explain using the example. For this particular tree, the maximum depth is the number of node from the root to the longest farthest leaf node. So this is the farthest leaf node, you can see here, right? So the number of nodes in this particular path is going to be the answer, which is 3. So you can see that the output is 3. Even let me take one more example. So if I have a tree like this, so I have 1 here, then 2, then 3, then 4, then 5, then I have 6 here and 7 here. So for this tree, the maximum depth is going to be this particular path. You can see that we have 4 nodes here, right? So the output is going to be 4 for this particular tree. Now I hope you have understood the problem. So let's talk about the solution now. Now in order to explain the solution, I have written one example here. So this is a binary tree, and for this binary tree, the answer is going to be this particular path. But hold on, as a programmer, we need to tell the computer that hey, whenever you are given a binary tree like this, you have to return the number of nodes in this path, which is 5, right? How to do this? Let me start with the smallest possible node. So I can have a single node. For this single node, I know there is nothing below this node, like all I have is a null node, right? As a left and right child. So for this node, as I have a single node, so there is no doubt that the maximum depth of this node is going to be 1, right? Okay, now I can see that I have single nodes here. This is a single node, there is nothing below this node. This is again a single node. All leaf node are a single node, right? Okay, so this is again a single node. For all these nodes, let me assign the maximum depth as 1. So I'm going to choose blue color, and the maximum depth is 1 for all the leaf nodes. Fine. Now what about this particular part? This part. Let me draw this part at this position. So I will draw 5. Okay, so I have 5. Then I have 8 as the left child. And I don't have any right child, right? So I'll write a null here. For this particular 8, I know that the depth of this particular node is 1, right? Which comes from here. And for this null node, there is no any node. Null node basically means there is no node. So the depth is going to be 0 here. So let me write it here. If node is null, if node is null, in that case, depth is going to be 0. So depth is 0. Fine. Now, what about the depth of this particular node? So the depth of this particular node can be derived from the left and right child. Let me explain how. Either I can have, okay, so for this particular node, I can have this particular path as the maximum depth or this particular path, right? And I'm only concerned about the path which will give me the maximum depth, right? So I'm going to choose the left path, and this path is going to give me the depth of 1 and 2. So this way I will have 2 depth for this particular node. But how we have done this? How we have done this? Let's have a close look at this. I have this node, then I have the depth of left and right child. So let me call it left depth and right depth. So I'm not writing the whole thing, but which is depth here. So I have the left depth and the right depth, right? And I have chosen the maximum of these two. If you like observe closely here, so I have chosen the max. Why? Because I want the maximum depth. So I will choose the max of this one. And whatever is the maximum depth of these two, I have to add 1 because of this node, right? Because now this node is also going to be a part of that path. So if I have 1 here, then I will add 1 and then I will have total depth 2, right? So I'll do 1 plus. And this is my answer. At every point, the maximum depth can be calculated by doing simple this particular thing, right? So this is all we need to do. This is all we need to do. So now what I can do is I can write this is going to act as relation, and I'm going to write the solution now. So let me write the code here. Let's say I have a function which is going to give me the maximum depth. So it is going to return an integer, and I have a function depth, and inside this function I have something which is root, right? Okay, so all I need to do is, first of all, I need to get the left depth. Okay, so before writing this code, can I complete this particular part? Of course I can do. So for this, the depth is going to be 2. And after this, out of these two, I have to choose one for this particular node. And this way, I will have the depth of 3, right? So for this 2, the maximum depth is 3, which is this path. Fine. What about this one? Here the depth is going to be 2 for this node 9, and for this node the depth is going to be, okay, so 3, right? And out of these two I'm going to choose the max, which is 3. So this way I will get the depth of 4 here, which is 3 plus 1. Fine. Now I come to this particular point, which is our final answer. So I have to choose one of these two, and if I choose maximum, then I will have 4, right? And at last I have to add 1. So when I do 4 plus 1, then I will have 5 as the output. I hope you are able to understand this thing. The answer totally relies on this particular relation. Now I'm going to write the relation. So here I have to find the left depth. So left depth is going to be depth of root dot left. So this is nothing but a simple recursive call, right? This is a function. So again, similarly, I have to find the right depth. So I'll call the right depth equal to depth of root dot right. So this is my left depth and the right depth. Now I need to write the same line that I have written here, right? So let me do it. I'll simply return 1 plus maximum of like left depth and the right depth. So this is all about the solution. Now the question is, as this is a recursive function, so I should have a base case. And what can be the base case? Let's say I keep moving down, down, and then I come to this point. After this, I will again move down because this node is not null. And when I come to null node, then there is nothing to go down, right? Because there is no any left child for the null node. So at this point, I have to stop. And for this node, I know that the depth is going to be 0. So I have to write this case. If my root is null, in that case, I have to return 0, which means that the depth is going to be 0 for this case. Now this is the main solution. This is the main solution. And what is the time complexity of this code? The time complexity is going to be O of n, because this is going to traverse every node in this tree, right? So this is all about this problem. I hope you guys are able to understand the solution. Thank you.